Welcome, grade 12s, to the review of the 2023 November final paper, which is your paper 1 in this case. I'll be reviewing question 1 in this video, which is algebra. Okay, let's get into it. Right. So now, question 1.1, solve for x. Well, in the first case here, 1.1.1, we have x squared plus x minus 12 equals to 0. So now this is your normal solve for x type of question that you're going to find. Okay. So now I want you to know that your question 1 links to two functions, right? So now if you can view from 1.1.1 up until 1.1.4, there's going to be a relationship between these questions and functions. So if you are able to answer these questions fully, then we know that you stand a chance whenever you're asking or you're answering your function-based questions. Your question 3 is 4, I think, if it's 4, 5, 6, as long as it's functions, but you need solid background on these ones here. Okay, let's get into the first one then. we have x squared plus x minus 12 equals to 0, like that. Okay, now, so it looks like they're being generous. They're giving us 3 marks for this. So what we're going to do, since this is a trinomial, we are going to factorize. Okay, so we're going to have x in bracket here, or we can open 2 brackets of x and then equate it to 0, right? So now we're going to look for the factors of 12. We're going to look for the factors of 12 that when I add them, they're going to give us a positive 4. So when I multiply them, they must give us negative 12. So I can think of a negative 4 or a negative 3 rather, and a positive 4. So this will be positive 4 here and negative 3 like that. Okay. And now for the final values of the answer here, we're going to have x equals to negative 4 or x equals to positive 3. So now I want you to think of this as if you are solving for the x-intercepts of a function, because x squared plus x minus 12, this is a parabola, right? So now when you're equating it to 0, remember, that's the same as solving for your x-intercepts like that. So this is going to be very important. So this will be 1.1 like that. Okay, let's go on. Now for 1.1.2, we have 3x squared minus 2x equals to 6. Okay, now on the side here, we have a statement that says we must solve this to 2 decimal places. Answer correct to 2 decimal places. So now what this tells us is that, well, this equation or this function does not have factors which are what? Are whole numbers, or the x-intercepts are not whole numbers, right? But rather, they're going to be decimals. Okay. So now, in such a case, you're also being directed to which equation you can use, right? So it means that we are going to use our trusted quadratic formula in this case to find the values of x, since we cannot use the operation of factorizing on this question. So first thing that we're going to do, we're going to have it such that it's equal to 0. So we're going to have 3x squared minus 2x minus 6 equals to 0. Then now we're going to employ the formula minus b plus the square root of b squared minus 4ac all over 2a. Okay, so now one mistake that we usually see is that this negative b is not catered for, right? So now the negative b is also part of the denominator. You should not write or start your division line from the square root and leave the negative b hanging. Okay, mathematically that represents something else or something different rather. Okay, now we're going to substitute in our values of a, b, and c. So if you did not know, hopefully you know, this here is going to be our value of a. The 3, the one next to the x squared, the constant next to x squared, or the coefficient next to x squared is a. The coefficient next to x, that will represent our b, and the constant there at the end that represents our C like that. Okay, so now we're going to have negative into -2 plus minus square root. We're going to have -2 all squared minus 4. And for our value of A, we have 3, -6. And now all over again, which is 2 into 3 like that. Okay, so now our values of X in this case are going to be X equals to. Now we're going to punch in your calculator and you're going to test for both the positive and the negative. So now when I punch in for the positive here, I get 1,79. That would be rounded off to 2 decimal places. Or X equals to, now that would be for the negative case, it is -1,12 like that. So these are the values of X that we get. Okay, now let us go on here. 1.1.3, we have square root of 2x plus 1 is equals to x minus 1 like that. Okay, so now we're going to solve for x in this case. So since the x, one of the x's is in the root like that, we want to get rid of this root like that. So we're going to have 2x plus 1 equals to x minus 1. And we're going to square both sides because we want access to the x that is inside the root there. So now in the case, since the square root is isolated or is alone, is a term alone on one side, we don't need to move anything else. So this becomes easy, right? So now opposite of square root. So we know that this will cancel that. And we're going to be left with the contents there. So we're going to have 2x plus 1 is equals to. And now this guy here would have to be expanded. This would be the same as x minus 1, x minus 1 like that. So now when you multiply throughout those terms like that, you're going to have x squared minus 2x plus 1 like that, right? And what we're going to have is a quadratic equation. It's going to be a quadratic equation. Okay, so it means that we have to take everything to one side and solve for x. So we're going to have x squared minus 2x plus 1. Now I'm taking these terms to the other side to join the x squared. And we're going to have minus 2x minus 1 all equals to 0. So now we're going to group like terms so that we can have a cleaner quadratic equation. So we're going to have x squared minus 4x. Now this is a positive 1, that's a negative 1. So they're going to cancel out in this case, and we're left with 0 like that. So it means that when we want to solve for 0 in this case, since this is a binomial, or we have two terms in this case, we're going to have to factorize like this. So x, and then we're going to be left with x minus 4 in the bracket. So now if we're going to obtain a 0 here, it means that either this x is 0 or the bracket here simplifies to 0. So the value of x that you might put in here might give us 0. So we know we're going to have x equals to 0 or x minus 4, it must give us a 0. And this means that for us to get a 0 here, this x must be positive 4 like that. Okay. Now, if ever we are solving a question that has a root, with it, it means that you have to test the values because not both values are going to be solutions. They're going to be viable solution to this equation here. Yes, whenever you're solving, remember that this x equals to 0 and x equals to 4 are not solutions for this equation up here. They're a solution for the modified equation, which is this guy here. They're the solution of this modified equation. Remember that we squared both sides at some point. So we need to test which one of the two here is going to be a solution here. So we're going to test. But you don't need to write it on your paper here. You don't need to write it on your paper. You can do it on your calculator, but I just want to show you that we have to test. So we're going to test the value of 0 in this case. So we're going to, wherever there's x, we're going to substitute 0. So we're going to have 2 into 0 plus 1 equals to 0. minus 1. So we're going to check if the left-hand side indeed gives us the right-hand side. So now this is going to give us a positive 1, and this is going to give us a negative 1. And positive 1 is not equals to negative 1. Therefore, this guy here is not a solution. So we cross it out like that. X is not equals to 0, right? Because left-hand side, in this case, LHS is not equals to RHS. So that's how we know that 0 is not a solution. Then we can test the other value in this case. So it's 2 into 4 plus 1 equals to 4 minus 1 like that. So this side we're getting a 3. This is 2 times 4, 8 plus 1, 9, square root of 9, that is 3. So in this case, we indeed see that X is equals to 4. Even though I don't think you'd have to write there for them in that case, but then that's how I usually do it. Now, please remember that whenever you see a square root, it is a must for us to test. So in this case, RHS is indeed equals to LHS. That's why we took 4 as our solution to this equation, which is the one that we started with there. So whenever you see a square root or a root somewhere and you're solving for X, you have to test those X values that you're going to get. Okay, let's go on to 1.1.4. Okay, so now 1.1.4 is an inequality. So what we have here is x squared minus 3, not 3x, minus 3 is greater than 2x. Okay, so now whenever you are dealing with an inequality, what I want you to think of is that this is where you are finding where the function is either positive or negative. So here we're actually finding where the function is either positive or negative. Okay, so now remember that your question 1 algebra is linked to functions, right? So now in this case, we are looking for where the function is either positive or negative because we are dealing with an inequality. Okay, so now let me have this inequality in a standard form, and then we can continue the idea of why am I thinking about it as a function. So we're going to have x squared minus 2x minus 3 is greater than 0 in this case. Okay, so now the function or the inequality is made up of 3 parts. This guy here, x squared minus 2x minus 3, this is a parabola. So we can think of it as a certain function f of x. Okay, and in this case, 0 here represents what? The x-axis. Okay, the x-axis, which is also known as the y is equals to 0 line. So now here it's a comparison, right? Between what? The function and the x-axis. It's a comparison between the function and the x-axis. So here we have this guy here. We have the symbol greater than. In this case, when I'm reading it from left to right. We're saying f of x is greater than the x-axis. So you can think of it in a couple of ways. You can think of it as what? As above. So f of x is above the x-axis. So we are looking for the place where the function is above the x-axis. So greater in this case can be linked to what? To above. If you're going to think of it in a diagrammatical manner, right? And then you can also think of greater than meaning as positive. If we're going to think of it as in terms of numbers, you're saying f of x is greater than 0. It means that you're talking about positive numbers, right? Where the y values of this function are what? Are positive values. Okay. So those are the 2 ways we can think about it. So if I'm going to have a diagrammatic representation of what I'm talking about here, is that I can have my x-axis here. I can have my x-axis, and now I can sketch, or I can have an outline of this function f of x. Because in this case, the only thing that I care about is the x-axis and the function. So now I need to know the shape of this function. Will this parabola be concave down or concave up? Now, in this case, when you're looking at the value of a here, you see that a is positive, right? So it means that our function is going to be concave up like that. It's going to be concave up. And now let's go back to the idea that says we're finding where the function is either positive or negative. So here we have f of x is greater than 0, meaning that f of x is above the x-axis, or the y is equals to 0 line in this case. So you and I can notice that the function is above at this point here. Starting from this point, going up like that, right? So that part, I can shade that part. We know that the function continues on in that direction. Or another part that is above the x-axis is this part here going on in that direction. So what you and I need, we need these values here. Where does it start? Those are going to be our critical values. So I can say that this is x1 here, and that point is x2. So it means that the function is above the x-axis. The function is above the x-axis when x is less than x1. So meaning starting from x1 going back like that, right? If I look at the x-axis, if I start from x1 and I go back, or values which are smaller than x1, I will see that the function is always above the what? The x-axis. The x-axis being this line here. Okay. And another part is that if I go from x2 here, going above, taking values which are above x2, I see that the function is always found above the x-axis. So meaning that this point here, x greater than x2. So it means that our answer will be in this form. Our answer will be in this form. It means that what we have to find is this value of x1 and the actual value of x2 like that. Okay, let's go on. So for us to find these values of x1 and x2, these are our critical values. So we're going to say, well, if we're looking for the critical values here, so we are allowed to say x squared minus 2x minus 3 is equals to 0. We're looking for the values where the function cuts the x-axis so that we know where to start reporting our answer here. So this is the same as opening two brackets and equating to 0 here. So we're going to have 3 and 1. In this case, it's going to be minus 3 and positive 1. So we have x equals to positive 3 or x is equals to negative 1. So this means that x1 in this case, which being the smaller value, is negative 1, and it means that x2 is equals to positive 3 like that. So now taking it from this form here, we're taking it from this form here, and we're going to report our answer. So it means that x is less than x1 or x is greater than positive 3 like that. And when you're using the graph or the function like this, which is diagrammatic, you are going to, this is the approach that you can use. But we have another approach as well where we can use the number line. Okay, so now whenever you are using the number line, well, you're going to have your x-axis again here, your x-axis. Okay, and instead of drawing this, you are going to look for your critical values. If ever you're going to use this approach, you're going to look for your critical values. In this case, we found them as -1 and positive 3 like that. And now we were going to test. Look at this, right? We are comparing the function to the x-axis. We're saying, where is the function greater than 0? In other words, where the function produces positive numbers. Okay, so it means that on the number line, we are going to check where is the function positive in these different intervals. So we have 3 intervals here. Interval which is negative, less than -1. The second interval being between -1 and 3, and the third interval being greater than +3. So now you can use test values now. Okay, let's use test values. I can plug in a number into this equation, right, which is less than -1. And I'm going to look for the sign of that number in this case. So if I plug in a -2 here into this equation, I plug in a -2, you will see that I'm going to get a -5. I'm going to get a -5 in this case. I don't care about the actual value here. What I care about is the negative, the sign of that number. Okay, so I'm seeing that here I'm getting a negative, and now I'm going to check what number or what's the sign if I use a test case here. So if I use maybe a test value of 0 in this case between -1 and 3, because that's a number that is found between -1 and 3, you'll see that I'm going to obtain a, well, in this case, I think I made a mistake. This should give us a +5. Yeah, that gives us a +5 like that. So here in between, we're going to get a -3. So we don't really care about the value, as I've said. We care about the sign of that value. So in this case, we are looking at negative. And in this case, I can take another test value, which is greater than +3, so that I can find the sign associated with this interval. And I can use +4. And you'll see that when I use +4, the number that I'm going to get here is +5. But as I've said, we don't care about the value that we're getting. We actually care about the signs that are associated with this interval. So it means that here we have a positive. For this interval, we have a negative. And for this interval, again, we have a positive like that. So if I continue or write my number line, I'm going to have my dots on top of my critical values like that. And now I am going to attempt to answer the question. They said where the graph is producing values which are greater than 0. So now I'm producing values which are greater than 0 on this side, starting from -1, going that side. So now I want you to see something. I'm not shading my dots here. This is because we don't have inclusion, right? You can only shade your dot if it was greater or equals to, that part equals to allows us to shade the dot. So in this case, we're not shading the dot. And where else is it positive? Well, it's positive when you're starting from 3 going that side like that. So now this is the same thing as saying x less than -1 or x greater than what? +3. Now, whenever you're reporting your answer, if you're using the number line, you are not going to use your test values. These are test values here. These are test values. We are not going to use those test values. Whenever you are reporting your answer, you are always going to use your critical values in this case. Okay, that's it on 1.4 and inequalities. Let us move on to the next one. Okay, so we have a simultaneous equation, which is 1.2 here. Okay, so now the idea behind the simultaneous equation is you are going to find the point of intersection or points of intersection between 2 lines, all right, or between 2 curves. Okay, so in this case, we're given this curve here, which is x plus 2 or line, which is equal to 2y. And we're also given this line here or curve, which is 1 over x plus 1 over y is equals to 1. Okay, so we can say, well, this guy here is equation 1, and we can say this is equation 2. So now whenever you're solving a simultaneous equation, the idea is that you are actually solving where these 2 functions meet their point of intersection. So we are going to try and find the coordinates. Okay, so let's go on. Between these 2, what we are going to do is we're going to take from the simplest equation, we are going to form equation 3. And equation 3 will always be in the form of x is equals to, so meaning that we're going to be making x subject of the formula, or we'll be making y subject of the formula here. So between the two, the simplest one, between the two, you take the simplest and you make either x or y subject of the formula, depending on which variable is easy to make subject of the formula. So from this one, from equation 1, I can take it, since it's the simplest between the two, and I can make x subject of the formula here because it's easy, right? I wouldn't have to divide by 2. You can if you want to, but in this case, it's easy just to make x subject of the formula. So I'm going to have x is equals to, now I'm taking this guy, the 2 to that side, I'm going to have 2y minus 2, and I'm going to call this guy equation 3, right? So now what we're going to do, we're going to substitute into equation 2, or the equation that we did not touch, so that we have an equation that is in terms of one variable only, and we can deal with that variable. So I'm going to sub 3 into 2 like that. So I'm going to have 1 over, wherever there's x, I'm going to replace with 2y minus 2. So I have 2y minus 2, and this 2y minus 2 goes as 1 term. So it's plus 1 over y is equals to 1. So now we have an equation that is in terms of one variable, in this case it's y, and we are going to solve for y. So since this is a fraction, I'm going to have an LCD here. I'm going to try and find the LCD, and the LCD is found by multiplying the denominators in this case. So it's y multiplied by 2y minus 2. And now I'm going to find the values that go into the numerator, so I can cross multiply y multiplied by that one. Then I'm going to have y. So 1 multiplied by y is y. And I had a plus in between the values, so I'm going to replace back my plus like that. And now this 2y minus 2 goes as 1 term. And now I'm going to multiply it with that one. If it was any number, if it was any other number, let's maybe say it was 5, I was going to say 5 multiplied by 2y minus 2, and this 5 would have to multiply both numbers in the bracket. So now it means that when I have 2y minus 2 multiplied by 1, it will say 1 multiplied by 2y to give us 2y, and then we're going to have 1 multiplied by minus 2, which is going to give us negative 2 still, which is again equals to 1. So now what I have is a fraction, but it's much more simplified, and I would like to change this from this fraction into something more linear. Okay, so it means that I'm going to remove the denominator by multiplying by it both sides. So I'm going to multiply by the denominator both sides. I have y into 2y minus 2, and then this removes that, and this side on the left-hand side, we're left with y plus, this is going to give us 3y minus 2. I've added like terms that side, and now you can multiply here. So 1 times y is still y, and then now we can multiply the y into the bracket. So we're going to have 2y squared minus y. Now, since this is a quadratic equation, what we're going to do is going to put everything into one side and equate it to 0. So 2y squared minus y minus 3y plus 2, we're going to get a 0 like that. So this simplifies to 2y squared minus, am I missing anything here? I think I'm missing a 2 here. Yes, I'm missing a 2 here, and I'm also missing a 2 there. So it's 2y squared minus 2y as well. Okay, so this is going to give us minus 5y plus 2 equals to 0 like that. And we can factorize this guy quickly. We're going to have 2y, and we're going to have y this side, and it means that this side we must have a 2, and we're going to have a 1 there. So both of them are going to be negative values. And now we can solve for our y. So for this bracket, we're going to have y is equals to 1, and then we're going to divide by that 2. So it's going to be positive 1 over 2, or our y is going to be positive 2 like that. Okay, so now we have found our values of y, and we can go back to equation 3 so that it assists us in finding the values of x. So what we're going to have here is, we're going to say x is equals to 2, and equation 3 was in the form of 2y minus 2. So we're going to have 2 into half minus 2, and this is going to give us, so this is going to be minus 1, because this is half of 2 is 1, 1 minus 2 is minus 1. Okay, or we're going to have x is equals to, now we're going to substitute in the value of 2 in this case. So it's going to be 2 into 2 minus 2, and that will be 4 minus 2, giving us 2. And now we can have, or it can be written in the coordinate form that says minus 1, the value of minus 1, and the y value is 1 over 2. And this side, the x value is 2, and the y value was 2 as well. So we can have it. So it means that these two lines, they meet at these points. They meet at this point of minus 1.5 and 2 and 2, like that. Okay, so that is that question of 1.2. Let's go on to 1.3. Let's just add a page here. We have run out of space. So add a page. Excellent. Okay, right. So now this question, let's go back to the question quickly up them. Let's go back to the question itself. It said, given 2 to the power m plus 1 plus 2 to the power m is equals to 3 to the power n plus 2 minus 3 to the power m. So they're saying where m and n are integers, meaning that m and n are whole numbers, which can either be negative or positive. They want us to determine the value of m plus n, like that. Right. Let's go on back to our station. So this is 1.3, right? So we're given 2 to the power m plus 1 plus 2 to the power m is equal to 3 to the power n plus 2 minus 3 to the power n. And what are we looking for? We're looking for m plus n. What is the value when we add these two things? So it means that maybe we can find the value of m and find the value of n afterwards. Okay, so now this is what we're given. It means that this is what we're going to do. So we have 2 to the power m plus 1. I can write this in terms of its factors, right? So remember that whenever you are multiplying like terms, you're going to add exponents. So it means that the factors here were 2 to the power m times 2 to the power 1, like that, right? So because when you multiply the like terms, you added the exponents. So these are the factors of this guy. So it's plus 2 to the power m as well, this side. So I'm going to do the same thing this side. We're going to have 3 to the power n times 3 to the power 2 minus 3 to the power n. Now, in most cases, whenever you're solving for x or you're doing algebra, whenever you're solving a question, in most cases, you would have to simplify it. Sometimes simplifying it means factorizing, factoring out some of the terms, canceling out whatever has to cancel, and so on and so forth. So this is what we did here. We wrote the terms that have factors, we wrote them in terms of their factors. And we see where can we go from here. Okay, so now from step 2 here, what we can do, I have a common factor of 2 to the power m, so perhaps I can factor out the highest common factor. So I have 2 to the power m outside. Now I'll be left with 2 plus 1, like that. And this side, I have a common factor or highest common factor of 3 to the power n. So this would be 3 to the power n, and I'll be left with 3 to the power 2 minus 1, like that. Okay, so we have 3 to the power n multiplied by, now 3 to the power 2, that will be 9, 9 minus 1, that's going to give us 8. And this side, we're going to have 2 to the power m multiplied by, so this 2 plus 1, that's going to give us 3, like this. Okay, so what we want to do is that we want to have it in same base, right? We want to change everything into same base. So we're going to have 2 to the power m times 3. We cannot change these ones. 3 to the power n. We can change that one as well. But this guy here, we can change it to same base, so such that we have a base that's common, or that's here in the equation, which would be 2 to the power 3 like this. Okay, now by the power of the equal sign, it says that whatever is on the left is equal to whatever is on the right. So on the left, we have a 3, and on the right, we have a 3 as well. So, and it's multiplying to a 2, and it's also multiplying a 2 this side. So it means that I can say this 3 belongs to this 3 to the power m. And I can also say that this 2 to the power m belongs to what is this? It's this one here. So this one is that guy here. Because on the left, the only term that has a 2 is 2 to the power m. And on the right, the only term that has a 2 is 2 to the power 3. On the left, the only term that has a 3 is that 3 to the power 1. And on the right, the only term that has a 3 is that 3 to the power n. So it means that, well, I made a mistake here. It's supposed to be n. Supposed to be n. And so it means that this 2 to the power m is, or it's this 2 to the power 3 like that. So this means that since the bases are the same, therefore the exponents are the same. So it means that n is equals to 1, and it means that m is equals to 3 in this case. And remember that they wanted the value of m plus n, which is what? 3 plus 1, which is 4, like that. And that's how you defeat question 1. Well, question 1 wants you to keep on practicing. If we can have question 1 nailed down, then we are sure to win the entire paper. Now, thank you for joining me in this review, and I will catch you on the next one. Cheers.